I have 10 Python questions that go from very easy to very hard. You're never gonna answer all of them. Let's check your knowledge. My name is Andrew. I'm gonna start. Here we have the first question. It may be easy for many of you, but some may struggle with it. So we have a list of A, which is 1 to 3, and then we're saying B equals A. Then A from index 0 equals 10. What is the value of B? Many of you may know that the value of B is gonna be 10 to 3. And that is because of Python memory management. So we use links or pointers in Python. Because Python is in CPython, and Python memory management is all about links. So basically, when we're saying A equals 1 to 3, and then we're saying B equals A, we're using the same object with B and A. So B is A, B is that 1 to 3 object. So A and B point to the same object in the memory. I have other videos on how Python memory management works, so you can watch all of them in order to understand that fully. But in simple terms, we point to the same object, and when we change B or A, both of the objects changed because that is the same object. B and A are the same, they just point to the same memory location. Questions are going to be harder now, but that is pretty simple for most of you. So we have function called A and we print 1 to 3. But then I'm saying A.x equals 10 and print A.x. What's going to happen? Are we going to have an error? Are we going to have something like, I don't know, what's going to happen? That's my question. Well, it turns out that we're going to just receive 10 as the result. Why is that? Because in Python, everything is an object and function is an object as well. We can use functions as normal Python objects. So we can say a.x, have an x variable inside of that object and say that it's equal to 10. And then we can call it. Nothing inherently bad here. Of course, it's not the best practice in 99% of the cases because when you create a function, you're supposed to use it as a function. But for some programs, it may be beneficial. So that's how it works. We can use anything as an object and a.x is not an exception. So here is my third question. We have myList class and it inherits from a list. Then we have append function that accepts an object and instead of appending that object to our list, it just returns hello. So what's going to happen? Because list as a parent class is pretty unusual. We create our list, we're saying mylist.append1 and print mylist in order to see the result. So what's going to happen? Are we going to have list with 1 inside of it or are we going to just receive hello and an empty list? It turns out we're going to receive an empty list and hello. But what is the problem with that code? Because many of you may say that if we overwrite append function or replace it with our own append function, we can just use the Python append function from our list. It's pretty obvious. But my question is, what is the problem with that code? And the answer is, we cannot inherit from internal types in Python. So lists, sets, strings, integers, booleans, all the built-in types are not inheritable. Why is that? Because actually, list is not a class. It's a C struct. So many of you may know that we're using CPython by default. And in C, we don't have classes. We only have structs. And a list, string, and all the built-in types are structs in C. And it's going to be really hard for you to make them work properly if you inherit from them. Because sometimes they may optimize your code and go directly to C instead of calling that append function in Python. So unusual behavior, bugs, all of that can happen if you inherit from a list. If you really need to inherit from a list, what you can do is from collections, import user list. And you also have user dict, user string here, and all the other types. And you can use it just like that. But typically, I think that just using array inside of the object is a better practice. The fourth one is for you to relax, because many of you know the answer to that question. So what is the problem with using try, 1 divided by 0, except print 1 to 3? And y divided by 0 is just an example. It can be any code inside here. So what is the problem with that except? Well, many of you may know that we don't want to use except without any concrete exception following it, like exception, or even better value error, or even better zero division error in that example. Why is that? Because if we use bare except, we may use some errors and we may handle some errors that we are not supposed to handle. For example, memory error, when your program does not have enough memory. You might handle them, but yeah, there are some exceptions that are not supposed to be handled, like memory error. What are you going to do with a memory error? Typically, it's not the best idea. It's better to refactor your application or do something else about it. Yeah, just using bare except is bad because you can catch any exception. And we don't want that. What we want is either using exception, but that's bad as well, or using something concrete like zero division error. Alright, so that is an interesting question. It may not be that hard, but it's interesting. We have a list 1 to 3, and we're saying A from 0 equals to A. What? A points to A. What's going to happen? Are we going to have an error? Are we going to have something like, I don't know, A with at least 1 to 3, then 2, 3? What's going to happen? It turns out that we're going to have an infinite list. So you see that we have 1 to 3 here, and when I'm saying A from 0 is A, there is an infinite list here. And what I can do is go to A from 0, run it again, and I'm going to receive the same list. Why is that? Because we go to the same memory location all the time, and I can put as many indexes as I want, and I'm still going to receive the same list, because that's an infinite list. I'm not sure how you can use it, but you can create infinite lists in Python. So you see that you have an infinite list because you point to the same memory location. That's really, really important, because Python memory management and Python itself is all about links. You can put a lot of bugs in your code if you don't know how the memory works. So that's really important. Once again, I have a video, maybe it will pop up right here about Python memory management, and you should watch it if you don't know how all that works. The sixth question is for you to understand how tuple works. So basically we have A as 1 to 3. Then I'm saying B is list A and true. And then I'm saying B from 0 dot append 10 and B from 1 is false. Which of those operations can be executed? Well, many of you may say the first one, so B from 0 dot append 10, because a lot of you know that tuples are immutable, so we cannot change the tuples. But actually, tuples are only immutable in terms of their structure. So if I call that B from 0 append 10, I can see 1, 2, 3, 10, true. But what is the problem? The problem is that my list was 1, 2, 3. And basically, I changed the value of my tuple. But that's not how tuples work. All of the tuples are only immutable in terms of their structure. So the structure itself, do we point to the same memory location as we pointed before? So we have 1, 2, 3 somewhere in our memory. We're saying B equals A and true. We are saying that you, tuple B, should save link A and link true. So the memory location of the things that you're saving in that tuple should not change. When I'm saying B from 0 dot append 10, I'm not changing the memory location of that list 1 to 3, because I'm saying just add one value to that list. Why do we need to change the memory location if we just add one value? However, when I'm saying B from 1 equals false, I'm changing the memory location from true to false, because true and false are located in different memory chunks. So your tuple is only immutable in terms of structure. You cannot change the structure of a tuple, but you can definitely change the values in the tuple if the values are mutable. So list is a mutable value. That means that we can change it. True is immutable, so that means that we cannot change it in any way. But we can change immutable values in tuples. Many of you may say that it's not advised to use lists in tuples or any immutable value in tuples, and I'm gonna say yes, it's not. But it's just like a question, so for you to know that tuples really work in terms of their structure. They do not check the values. Alright, and now the seventh question. It's gonna be the hardest one. And why is that? Because I found the answer to that question completely randomly. Imagine that you have a tuple 1 to 3. But instead of using the tuple, we just print hash from hello. So we just print hash from hello. And many of you may know that hash is a value that is the same for the same values. So if I have hash hello in my program 2 times, so hash hello and hash hello, the value itself is going to be the same in terms of one program run. So you can see that the value on the left is equal to the value on the right. If I rerun my program, the value itself is going to change. But in terms of the program, the value is always equal. So if I'm saying hello and hello once again, the value is going to be equal. Run again, run again, run again. So you can see in terms of different program runs, the value will change. But in terms of the program itself, the value is going to be the same. Imagine that we have a tuple 1 to 3. And we're saying print hash from A, print hash from tuple 1 to 3. I'm going to run it one time. Here is our hash. So everything is great. Tuple is immutable because we can only calculate hashes from immutable values. But if I run it again, will the hash change? Many of you may say yes, because I asked that question. But why is it going to change, or why is it not going to change? Well, it turns out that it's not going to change. You can see I'm running it like 10 times already, but it's not changing. Why is that? Because as I said, tuple works in terms of structure, and hash is a function that returns the result in terms of the value that you have in your structure. So in our case, in terms of the value inside of the tuple. And what tuple does, it uses the links inside of 1, 2, 3. So it gets a link from 1, so where 1 is located, where 2 is located, where 3 is located. And then it calculates the hash. But 1 to 3 are constants. they do not change their memory position in our computer. So that means that each time I run my code, 1 to 3 are gonna stay in the same memory chunk. That means that hash from A will point to the same, so our tuple will point to the same memory chunks. And that means that if we point to the same memory chunks, hash from A is going to be the same. And even if I put like 2500, I can see that the hash itself changed, but yeah, that's because I added a value, but it's not going to change. And the 8th question is for you to ask. So if you have any interesting questions that you want me to answer, or if you have any interesting questions, just write them down in the comments. My name is Andrew. Thank you for watching. Subscribe to my channel, leave a like, leave a comment. Make sure to write your score and your own question. Thank you and bye bye.